So as I was saying, okay, we know how to graph something that's in this form, right? Where we have y equals mx plus b, right? We spent a whole bunch of time trying to figure out how to graph stuff that looks like that. Here, I'll make this bigger. Okay, and but we haven't spent any time figuring out how to graph something like this, and we have two options at our disposal for something like this. So I'm going to show you the first one just for practice. So if you weren't here, or if you're still struggling with this, okay, I'm going to give you a sheet today that has y equals mx plus b on one side. You can continue practicing, and then on the other side, it's all this other form. Okay, and so you can practice. You get lots of graphing practice today. Okay, and so our goal is, because it's a little easier to graph stuff with y equals mx plus b. Our goal will be to, one, we're going to switch this form. And what do we, does anybody know what we call this? I've mentioned it before. Kenneth, yeah?
It's standard form.
It's standard form. It's a standard form of a line. And standard form of a line follows something like this. Will be ax plus by plus c equals 0. Okay, and the gist is, there's some rules with this, and I'll go over them, okay? But all you can see here, here's A, there's B, and there's C, okay? And there are some basic rules with this. There's no fractions allowed, and A can't be negative, okay? And so you just manipulate the final. That's not a big deal. It's just a formality thing. But you'll notice A, there's no fractions in that, and A is not negative, okay? So I'll guide you through that, okay? So, but for right now, I want to show you how to, because we spent a bunch of time going over how to graph something that looks like this over here. I want to switch it into that form, okay? And so we can use some of our solving methods to do that for us. So what do you notice about what I've highlighted in blue, or what the other equation is on the left? What's true? Like, what's on the left? Aaron?
You're basically just trying to find y.
Yeah. So I'm just like, remember we were spent all the last 2 days just solve for x, solve for x, solve for x. We got a number. This time, we're not going to get an actual answer because we got two variables here. We got x and y. But I'm in technicality terms, we're just solving for y. That's what we're doing. Okay, so we're just going to get y by itself on the left, and everything else is going to go on the right. And then we're going to be in y equals mx plus b, and I can graph that line like this, okay? Because I've shown you the skills on how to do that. Your y-intercept and your slope will become apparent that way. Okay, so the first thing I would do is I would just move stuff, right? Like there is multiplication division there, okay? But remember what we do first. We do all the easy stuff first. So if we're looking at Sam Deb, okay, it's reverse order, bedmass. Just move things that are a distance subtraction to the other side and do that using 0 pairs, okay? So first thing I could do is just add 12 to both sides, okay? And I can also take away 4 x's. Does everybody agree? From both sides. Okay? And then you've created these 0 pairs. So the only thing you're going to have left on the left side now, there's a 0 pair, and there's a 0 pair. You're going to be left with 3y is going to equal negative 4x plus 12. Okay? So how do I get y by itself then? Yes? Just divide everything by 3. Everything. Okay, so I'm going to divide by 3 here, which means I'm going to divide by 3 here, which means I'm going to divide by 3 there. Then you're going to have, oh, there's a 1. So now I have 1y is equal to negative 4 by 3x plus, what's 12 divided by 3? Starts with an F. Ends in or. We say it in golf. That should be. Should have said that instead. 4. Should have said that. Missed opportunity there for a joke. Okay. All right. Everybody happy? Okay, so now, okay, if you weren't here, I'm going to show you how to graph this. Okay? So, first things first, a lot of you, what I think on the formatives and things, what I'm missing on the formatives, if you know this is your Y-intercept, this is good. I saw a lot of this. It's not that that's wrong. A Y-intercept is a point. Okay, and I know Ms. Farahani wants to see something like this. Okay, don't forget the brackets. If you just write 0, 4, that looks like a list of numbers that Mr. Ingman had up there earlier. Right? It's just 0, 4. You need to put the brackets on. Okay, for it to be a coordinal point. Okay, so there's your Y-intercept. That's where you start. So remember, if that's your Y-intercept, then I'm going to go find 0, 4. It's right here. Okay, the reason why I'm doing this is not everybody's on the same page yet. Okay, which is fine. It's not easy. I'm still seeing a lot of tables as well, and I don't want to necessarily see the tables because you're not going to finish EQAO. Okay, they're going to put a question on here. If you spend double the amount of time doing the table versus like just plotting it the way we've shown you, you're not going to finish. Okay, so just try to be efficient. Use the ways we show you because it's the most efficient ways. Okay, so we've plotted the Y-intercept, and then we could state what our slope is. Our slope for this question, remember slope is rise over run. And so it tells us it's -4/3. So I'm going to go down 4, right 3. And where do I go down from and right? Well, my starting point. My starting point is the blue dot on the page, right? That's my Y-intercept. So I'm going to go down 4, 1, 2, 3, 4, and then right 3. 1, 2, 3. And then you can do it again. 1, 2, 3, 4. 1, 2, 3. Okay, and then the opposite of going down 4, right 3, would be to go up 4, left 3. What does that look like as a slope? Well, you could go 4 over -3. Okay, so we can go up 4, 1, 2, 3, 4. 1, 2, 3. Okay, and that'll be good. All right. Does anybody have any questions with that? X and Y are labeled already for you. And then just make it a good habit too, because when you get to grade 10 and you start doing some graphing questions in grade 10, just get in the habit of going like this. Just label it. Y equals -4/3 x plus 4. Okay? Declan, you have a question? Okay, yeah. So you guys tell me if I've missed anything. I think I've got everything. X and Y are labeled. I've labeled my line. I've got my arrowheads. That implies that the line goes on forever, because I could continue to count up 4 left, or down right. I could do that forever, so you better put the arrowheads on. And then tell me what the equation is, or what the graph is, and the equation for it. Okay? And you've stated what your Y-intercept is. You're good. I think you've checked all the points off. Very, very descriptive as to like what's gone on there. Okay? Now, back on the very first day on when we talked about graphing lines, okay, we talked about another method, and it's actually up here. If everyone's done, it's up here. I think we talked about X and Y intercepts. Okay, if you think back. Okay, and so what I'm going to do here, I'm just going to pull a question off of the back of the sheet that I'm going to give you later. Something like, so we're going to scratch this out. I'm not going to do this question. We're going to go 2x minus 2y plus 5 equals 0. Okay. And the reason why I'm showing you this is because I don't know what they're going to put on EQAL, but they could very well put y equals mx plus b, but they could put this as well. And then what do? If I didn't show you this, I know you all know how to plot the line, and I know I've shown it to you, but EQAO wouldn't know because they tricked you by putting standard form there instead. Okay, and we couldn't just jump into doing that because I hadn't shown you how to like move things around an equal sign. Right, but I did show you, if I saw an equation written in standard form and the question said graph, I did show you x and y intercepts. Okay, so here's how this works. And this is how, if I saw something, this might be the method I choose to use to produce the graph, unless I state graph it using y equals mx plus b. What does a point look like for a y-intercept? So if I were to write, and I've already written one on here, okay, but if I wanted to solve for what the y-intercept was, what does a y-intercept look like as a point? It's got an x and a y, right? Does that make sense? So what's in the point then? What never changes for a y-intercept, I suppose is my question. Aaron?
X is always 0.
Exactly.
The intercept.
Yeah, y is just a number, right? So everybody agrees. So an x-intercept always has, sorry, other way around. A y-intercept always has this, 0 and some number. Would everybody agree? We already saw that over here on this question. The y-intercept was 0. It's always 0 for x. And it's always 0 for x because it has to cross the y-axis. Well, if it crosses the y-axis, its x value is 0. It doesn't have any left and right pieces, right? It's right on the 0. So this is always true for a y-intercept. So if you wanted to solve for the y-intercept, what you could do plug x equals 0 into the equation and solve for y. Watch what happens. Oops, sorry. I'm getting carried away here. What's 2 times 0?
0.
0. It goes away. What are you left with? Well, you're just left with negative 2y plus 5 equals 0. Can you please solve for y? Yes, you can, because I showed you a whole bunch how to do that. That's one of the two-step equation questions from yesterday. Right? So you're just going to solve for y. So I would deal with the plus 5. I'd create a 0 pair. Take away 5 from both sides. And you'd be left with negative 2y is equal to negative 5. Divide both sides by negative 2. Y will equal 5 by 2, which we know as being 2.5. Does everybody agree? So that's my y-intercept. My point is, I plugged in x equals 0. Does everybody agree? I took my x value of 0. I plugged it in, and I found y. So my point is 0, 2.5. That'll be my y-intercept. So you can go plot that. 0 and 2.5. That's right here. Okay? Now, what did I say you needed for a line? Remember, all I know right now is that the graph goes through that point. Everybody agree? So I could draw infinite number of lines. I could do this, I could do this, I could do this, I could do this, I could do this. So what do I need to create a line? Yes, Robin? A second point. And so is it not true that you have y-intercepts and also x-intercepts? So again, what I'm trying to get at is I don't know. You can pick whatever you want to do. I'm trying to give you the method that makes sense to you. Okay? Would I sit there and use a table of values to do this? No. Can you use x and y intercepts versus y equals mx plus b? Absolutely. You want to pick the one that makes sense in the situation. Do you want to use x and y intercepts if you have y equals mx plus b? No, because it's y equals mx plus b. Why wouldn't you just graph it? Right? But if you have something in standard form and it looks really complicated to untie, then go ahead and use x and y intercepts. It'll produce the line for you. Okay, so now I have this exact same series of questions that I just finished asking you, except we're not talking about where the graph crosses the y-axis anymore. We already found that. It's right here. What am I interested in now? I'm interested in where does the graph cross the x-axis? And so what is true about all the points along that big, thick black line I drew there? If I were to write any point along there, what's going to be the same thing across all of them? Merck?
The second, point is 0.
All the y values. So if I were to write out a point here, I'm going to have a number for x. If this is x and y, right? All the y values, you will all agree. Do I have any up and down values along here? No, I don't, right? They're all 0. Okay? So this is what we call an x-intercept. X-intercepts happen when y equals 0. So I'm going to do the exact same work, except I'm just going to plug a 0 in a different spot. And I'm going to get my new point, right? So that's what I'm going to do here. So I'm going to go, okay, 2x take away 2y plus 5 equals 0. If y equals 0, plug it in. 2x minus 2 times 0 plus 5 is equal to 0. Now some of you might be, and this just crossed my mind and I got a little complacent. I was thinking, oh, this is easy. It's gonna be 2.5 again. Positive 2.5. I got carried away in my own mind and then I caught myself. Okay, so don't get complacent. Just run through the process that I'm showing you, regardless of what you think is the answer. Okay, because if you jump to a conclusion, there's a possibility that it's wrong. Okay, and I'll show you what I mean in a second. So I'm going to get 2x. 2 times 0 is 0. 2x plus 5. Well, what am I solving for now? It's not y. It's x. Does everybody agree? So now just solve for x. Same thing. Take away 5, take away 5. So we're going to go 2x is equal to negative 5. Divide both sides by 2. Did I get positive 2.5 this time? That's a big difference, and I'll show you what that looks like in a sec. X equals negative 2.5. So that means my point is actually negative 2.5 and 0. Okay, that's back here. Okay, this completely changes the look of your graph, right? So here's our actual answer. Here's our line for this, and you could label this as you will, right? X and Y are labeled, but you could call this graph here. This is the graph of 2x minus 2y plus 5 equals 0. That's that graph. Okay? If you just got ahead of yourself, like I know it crossed my mind that I was going to say, oh, look at that. It's just the same thing again. I was going to go to positive 2.5. Look at the difference in these two graphs. They're the wrong direction. Right? It makes a difference. You got to be careful. One little sign. Look at the difference in those two graphs. One little sign made. The purple is the wrong one. Okay? You're off. All right? Just be careful. So sometimes they might put really ugly, like standard form questions on the test. I have no idea what they put on this thing. Okay, this is actually, you guys are the first ones I've ever taught that have actually written EQAO in grade 9. I've taught grade 9 courses before, but EQAO never ran. So this is my first time doing it with you. And it's a new curriculum, so it's literally it's a free-for-all. Okay? But what I'm trying to do is prepare you for all instances. Okay, and still ensure that you get done in time. Right? So anyway, does anybody have any questions of that? I would say if there's a standard form equation and it looks really ugly, I would graph it using the x and y intercepts so that you don't have all this hard isolation to do for y. If something's already in y equals mx plus b, then just graph it y equals mx plus b. I would avoid the tables. Okay? I think you're kind of done with the tables. We're gonna revisit tables in like grade 10 and grade 11 to introduce what a graph looks like, but then we're gonna give you skills to like work with those graphs. Same way I'm giving you skills to work with lines right now. Okay. So any questions on that one? I'm gonna hit stop on that because that's kind of a long video, and then I'll do the second page here. Okay. Oh.